For anything or everything to be displayed on the screen, the game data class holds that. So let's continue to develop game data class. So here we could have an array list to hold all the objects to be displayed in the game. So let's have a public array list of something here. We are going to do inheritance design. So anything to be represented in this game should implement, for example, GameFigure class. So that's an ancestor of any objects to be displayed in the game. Then we would have some group of objects, a game object. Let's call it fixed object. What I mean by that is, let me finish the code. What I mean by that is in the game, there must be something fixed, not just added or removed, like some main character you have. Then let's put that in this fixed object area. Import array list. And then for game figure, and then we would have another group of things in the game scene. Let's call it as a friend object, and then another one, let's call it as a enemy object. What we are doing is as follows. Suppose you have a shooting game that bullets or missiles are friends of the gamer. So, and then some enemies appears, UFOs, it's going to be enemy object. For the convenience's sake, we are going to classify into three groups, and later I will explain or rationale behind why I separated those into groups. And then let's define game figure. So in the model, anything to be on the screen, it should implement the game figure class, and this game figure class will be abstract since it cannot define everything until we have a concrete one there. So in the game figure, the first thing we would like to have a common to anything, the UFO or any enemy, and so it's the location of the object on the screen. So that's going to be public. Let's use a point2D class with a float. In computer graphics, float is sufficient. And then let's say location of that. And then another one, let's have a boolean done, which means when this object is done in the game, it should be removed from the game scene. So by looking into this flag, if that thing is done, like you shoot a missile, if a missile explodes, then we are going to remove it from the game scene. We are going to take a look at this flag done. Then let's have a constructor game figure where x, y locations are provided. Then we are going to create a point2D x and y. Here the game figure we could get a float directly, since we store in terms of float there. Another one is just for convenience's sake. Let's give a default constructor. Then let's give n0 and 0 there. And then once after the game figure object is created, we may need to relocate. Let's call it set location, where new location is provided. Then let's change x is x, location y is y, so we update those two. And then common behavior which cannot be defined in game figure would be public abstract void render. How we should render it on screen. Graphics 2D objects is provided there. Here, why do I use graphics 2D is recall the canvas, my canvas. What it did is in the double buffer mechanism. So render, when you render, we are going to render on off-screen graphics. This off-screen graphics is a graphics 2D object. So onto this off-screen object, we are going to draw something on that. So the game figure rendering is on this off-screen graphics 2D object. Another common behavior would be update. So at each frame, how we should update this game figure. If it's UFO flying to the right or left, that's update. A missile just travel along the path to the mouse click position and the like. And then one of the important things game is that we need to detect the collisions between game figures. If you shoot, then bullet should hit something, then we need to be able to detect the collision. And this collision is based on size of each game figure. So let's call it get collision radius. Then this refers to the size of this game figure. If it's a circle, radius is returned. Depending on shape, we just return some proper value for that, and using that, we are going to detect the collision. So in a later video, we will see how to use this one. Anyway, these are the common things for any game figure should appear. So for testing purpose, let's define one of the game figures. So here, let's just say missile extends game figure. Then it should implement many methods as we defined. So rendering is based on G2. So let's say draw oval or fill over with a color. So in rendering, let's set color blue, and then oval is 100. The size is width, height, and the like. Suppose the missile has a location there, so actually by default the game figures the default is 0 and 0, and the XY is there as a public, so you can have access to directly. So in the missile, let's have X as a super X, whatever is super location X is the one, and the super location Y. So given X and Y, then let's so game figure location is a public, then missile fill level requires all those in an integer value, so we should convert XY location in integer like that. And then let's say update is a plus plus X. X is increased. Super location X. X is incremented. That's the meaning of update. Then here is a typo. There. So here update means update everything here. So it will be a loop. So for any figure in fixed objects, just call update. That's the meaning of update. And then each figure in the friend object update. So in the same way, for every enemy object, update is the meaning of the update. So in a rendering part then, in canvas, in rendering part is for everything in the game data, we should just render that. So for main game data fixed objects. So let's get one by one. There, what you do is render by having G2 off-screen object. So similarly, in game data, any friend object there, each figure render with the off-screen buffer. Similarly, in everything in game data, enemy object just render with the off screen. So that's a general rendering mechanism. So anything or everything in game data will be in the loop updated and then rendered. So that's the game loop. So for test that, let's add or let's say before the game loop begins, let's say init game like that. Then here let's have a static void init game. So have some initial ones there. So what you can do is in game data for friend object, so let's add some game figure. So we have defined missile there. So in a missile, original location is default is 0, 0, but we can define some initial location such that it's a 50, 50 is the initial location of the missile, and the missile constructor is not provided. So let's define public missile as constructor location. It's there. Then super x and y, we just pass it to the super. Then we just create the initial location of a missile there, and then missile has update mechanisms. Every frame x is incremented. Rendering is like that. So let's test the entire program now. So here, as you can see, the missile like this shape is moving to the right. So every frame, just 1 pixel to the right is there. So I've shown you so far the purpose of a game figure, which is a common ancestor of anything to be rendered on the screen. And then that's stored in a game data class. So game data class has mainly 3 array lists. So depending on purpose or role of the game figure, just put that in proper location. We will develop that later. And then main game loop is each iteration, each frame, we update everything in the game data, and then we render that. So update in game data means for each game figure in each array list, just call update. Missile case update was this one. And then we render that onto canvas. So on canvas, what you do is that for each game figure in each game data group, just render, render, render. So that concludes the overall picture of the game loop, and I have demonstrated it. And very initially, I have created one thing called the missile, and added it to this group of the game data, and as a result, we have the animation where the oval is moving to the right.